Hello everyone. Today, we'll explore a very important topic in algebra: quadratic equations. A quadratic equation is a second-degree polynomial equation in one variable. Its standard form is ax power 2 plus bx plus c is equal to 0, whereas not equal to 0, where a, b, c are real numbers and a is not equal to 0. X is the variable. For example, x power to minus 5x plus 6 is equal to 0, or 3x power 2 plus 2x minus 1 is equal to 0. Now let's talk about the degree, roots, and nature of the roots. The degree is the highest power of the variable, which is 2 for quadratic equations. Roots are the values of x that satisfy the equation. We use the discriminant d is equal to b square minus 4ac. If d is greater than 0 and a perfect square, then we get real, distinct, rational roots. If d greater than 0 but not a perfect square, real, distinct, irrational roots. If d is equal to 0, real and equal roots. If d less than 0, complex, imaginary, roots. Let's now look at methods to solve quadratic equation. Let's understand the factorization method with an example: x squared minus 5x plus 6 equals 0. Now, we factor the quadratic. X squared minus 5x plus 6 becomes x minus 2 multiplied by x minus 3 equals 0. From this, we get two solutions, x equals 2 and x equals 3. So, these are the roots of the equation. Now let's move on to the completing the square method. Take the equation x squared plus 6x plus 5 equals 0. We start by shifting the constant to the other side. X squared plus 6x equals negative 5. Now, to complete the square, add 9 to both sides. X squared plus 6x plus 9 equals 4. The left-hand side becomes a perfect square. X plus 3 squared equals 4. Now take square roots on both sides. X plus 3 equals plus or minus 2. Finally, solving for x gives us x equals minus 3 plus 2, or x equals minus 3 minus 2. That means x equals negative 1 or x equals negative 5. Quadratic formula. The formula is x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Let's apply this to an example: 2x squared plus 3x minus 2 equals 0. That gives us two solutions, x equals 0.5 or x equals minus 2.
How do we find the sum and product of the roots?
Now let's understand how to use the sum and product of roots to form a quadratic equation. Suppose the roots of the equation are alpha and beta. Then, the sum of the roots, that is alpha plus beta, is equal to negative b divided by a. In short, alpha plus beta is minus b upon a. The product of the roots, that is alpha times beta, is equal to c divided by a. That means alpha beta is equal to c upon a. Now, if you're given the roots and need to form the quadratic equation, use this formula: x squared minus alpha plus beta times x plus alpha times beta equals 0. Or simply, x square minus sum of roots times x plus product of roots equals 0. For example, if the roots are 3 and 4, then the sum is 3 plus 4 is equal to 7. And the product is 3 times 4 is equal to 12. So the equation becomes x squared minus 7x plus 12 equals 0. That's how you form a quadratic equation from its roots. Now let's discuss transformation of roots. If the roots of an equation are alpha and beta, and we want a new equation with roots alpha plus k and beta plus k, we adjust the sum and product and form the new equation. Example: shift roots of x square minus 5x plus 6 is equal to 0 by 2 old roots, 2, 3 new roots, 4, 5 new equation. x score 9x plus 20 is equal to 0. Let's now learn how to solve quadratic inequalities step by step. Step 1. Solve the quadratic equation just like you normally would. Step 2. Plot the roots on a number line. These roots divide the number line into intervals. Step 3. Check the sign of the expression in each interval by picking test values. Let's take an example. We are given the inequality x squared minus 5x plus 6 is greater than 0 first. Solve the equation x squared minus 5x plus 6 equals 0. Factor it. X minus 2 times x minus 3 equals 0. So the roots are x equals 2 and x equals 3. Now plot these on a number line. This gives us 3 intervals, x less than 2, x between 2 and 3, and x greater than 3. Now test values from each interval in the inequality. Try x is equal to 1, the expression is positive. Try x is equal to 2.5, the expression is negative. Try x is equal to 4, the expression is positive. So the inequality is true when x is less than 2 or x is greater than 3. Final answer, x less than 2 or x greater than 3. Now, let's look at some common mistakes students often make while solving quadratic equations. Understanding these will help you avoid silly errors in exams. Mistake 1. Making sign errors in the quadratic formula, especially when handling minus signs in front of b. Mistake 2. Forgetting the plus minus symbol, that is, the plus or minus sign in the formula. Remember, it always gives 2 solutions, not 1. Mistake 3. Confusing the discriminant, which is just b squared minus 4ac, with the whole square root expression in the quadratic formula. Mistake 4. Assuming that complex roots mean no solution, that's incorrect. Complex roots do exist and are valid solutions in mathematics. So, stay alert, check your steps, and don't fall for these common traps. Let's now practice with some examples, starting from basic to intermediate level. Level 1 Basic Questions. Question 1. Solve the equation x squared minus 4 equals 0. This is a simple difference of squares. We can write it as x squared equals 4, so x equals plus or minus 2. Final answer, x is equal to plus minus 2. Question 2. Solve x squared plus 7x plus 10 equals 0. We factor this as x plus 2 times x plus 5 equals 0. So the roots are x equals minus 2 and x equals minus 5. Final answer, x is equal to minus 2, minus 5. Level 2 Intermediate Questions. Question 3. Solve 2x squared minus 3x plus 1 equals 0. We can use factorization or the quadratic formula. The roots come out to be x equals 1 and x equals 0.5. Final answer, x is equal to 1, 0.5. Question 4. Solve x squared minus 10x plus 24 equals 0. Here, the roots are in the ratio 2:3. That means the roots are 4 and 6. Final answer, x is equal to 4, 6. Solve x squared minus 8x plus 16 equals 0. We factor this as x minus 4 squared equals 0. So the solution is x equals 4. Final answer, x is equal to 4, repeated root. Let's solve the question, if the roots of the equation x squared plus px plus 12 equals 0 are equal, find the value of p. We start by using the condition for equal roots. The formula is d equals b squared minus 4ac equals 0. That means the discriminant must be 0. Now in this case, a equals 1, b equals p, and c equals 12. Substitute these values into the discriminant formula. P squared minus 4 times 1 times 12 equals 0. That simplifies to p squared minus 48 equals 0. Now solve p squared equals 48. So, p equals plus or minus square root of 48. Now simplify the square root. Square root of 48 equals 4 root 3. Final answer, p equals plus or minus 4 root 3. Let's quickly revise the most important formulas and concepts from quadratic equations. This is your final revision sheet. General form of a quadratic equation is ax squared plus bx plus c equals 0. The discriminant, denoted by d, is b squared minus 4ac. The nature of roots depends on the sign of the discriminant d. The sum of the roots is minus b divided by a. The product of the roots is c divided by a. Before we wrap up, let's remember three very important results in quadratic equations. First, the quadratic formula helps us find the roots of any quadratic equation. It is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Second, the vertex of a parabola, which is the highest or lowest point on the curve, occurs at x equals minus b divided by 2a. This tells us the line of symmetry of the parabola. That's all for today. Keep practicing and don't fear the quadratic equations. See you in the next session. Jai Hind.